Hello students. Today we are going to study various topics of Module 1, data abstraction, data independence, and database application architecture. Textbooks that we are going to use to study all these topics are database system concepts, then fundamentals of database system, and third is database management system of these various authors. What is my data abstraction? So data abstraction refers to the process of hiding data organization and storage details from the user. Data organization is hiding, we are hiding two things. One is data organization and second is storage details. From whom? From the user. So first of all, what is by abstraction? Abstraction means hiding of data. Hiding of data. Which data organization? We are hiding not only data, we are hiding the data organization, means how the data is stored in the database, that we are hiding. From whom? From the user. And along with that, we are hiding the storage details, where that data is stored in the backend, that we are going to hide from the user. So what is the need? For example, if we consider this website of IRCTC, so here when we as a general public or as a passenger, when we put the details of about from which station you want to find out the train to, then the date and the class, whether it is a first class, second class, and general means the quota, whether it is general or ladies quota or senior citizen quota, etc. So when we click on the search, we get the details from which source to destination, whatever the trains which are available on that route. When we click on the particular class, 1 tier or 2 tier, then we get the availability of the seats. So all these are the details we get as a passenger. But where this data is stored in the backend, which data it is stored, whether the passenger details are stored, train details are stored, route details are stored, availability details are stored, everything is hide from the user. Now, if this is an example, another example where the website of LIC website is there, we can see. So if we are the customer of the LIC, then after login, we can check that what are the facilities which are the available for the user. So customer portal, if the customer is NRI, then the NRI customer portal, pay premium online, other online services, everything is available for the users. So these are the web portals, or we can say the application through which we can access the data. But where the data, how the data is organized and where the data is stored, which is not required for the general public or the passengers or the customers. So that's why in the data abstraction, we are saying that this process of hiding irrelevant details from the user is called data abstraction, as the user do not require such details because these users are the end user. But if the user is a database administrator, then this data is important for the database administrator. Or if the user is application programmer, or the developer, then that developer require this data. But as an end user, we do not require these details about the data organization and storage details to the user. So that's why we are hiding this data from the user. This process is called as the data abstraction. So what are the different levels of data abstraction? There are three levels. One is physical level, second is logical level, and third is the view level. So what do you mean by physical level? Physical level means how the data is stored in the physically in the memory of the computer system. Logical level means how the data is stored in the database. Okay, means this, for example, if we consider the customer details, If the customer details we want to store, then we have to store the customer ID. For example, 101. What is the customer name? Smith. Then what is the name? What is the customer street? Then ABC and the city. For example, Pune. So in this way, we need that what is the describe how the data will be stored, whether it is in the form of integer or whether it is form of the string and so on. So this is a logical level, and third is the view level. View level means the external view, where through the application program, user gets the detail. So here through the application program, we hide the details of data types from the user because it is not required and display the contents as per the user role. User role, if the user is a customer, user is a passenger, then user will get the details. If the user has an account in the bank, then his details he can see. So these are the through application programs or through web applications. So views can also hide the information for security purpose because we do not want to show which data to which user. That is also important. As the admin has all the rights to see all the data, but as a customer or as a user, we don't have that right. So there are three kinds of levels of data abstraction. One is physical level, second is logical level, and third is the view level. So here we can see the architecture of database system. These three levels are physical level, that is the bottom level, middle is the logical level, and third is the view level or external level. So number of views, as we discussed that if the user is a customer or if the user is a database administrator or if the if the user is a customer or if the user is the admin or if the user is the uh, maybe the employee, etc. So they will get the different views. So this three-level database architecture allows a clear separation of the overall database view from the external user's view of the database and from the physical data structure layout. How the data is stored, what is the physical structure, everything is hidden from the user. The database system that is able to separate the three different views is likely to be flexible and adaptable. This flexibility and adaptability is called as the data abstraction. So we can see in this diagram, we also call it as a data DBMS three-level architecture. Why three-level architecture? Because there are three levels. One is the physical level, second is the conceptual level, and third is the external level. So this three-level data abstraction or DBMS three-level architecture consists of view level, which is the top level. Now, view level is also called as we can see in this diagram as view level is also called as the external level in the right-hand side diagram. External level, because these are the various end user, they get this view as per their requirement, as per their role. Now, second is the logical level. We also call it as a conceptual level. So conceptual level means the logical schema we draw. How the structure, complete structure of the database, how many relations will be there, how these relations will be relate with each other. Relation means the data or the tables in terms of RDBMS. Now, and the third is physical level. Physical means how the data is stored in the database. So this is the database, how the physically data is stored in the form of rows and columns, if it is RDBMS. So this internal level, we call it as the internal level. So this is the complete diagram for the DBMS three-level architecture or three-level of data abstraction. The three-level architecture presented in the figure above provided three different levels. So we again understand one by one all these levels. So first is the physical level. We also call it as the internal level. Internal means how the data is internally physically stored in the memory of the computer system. That memory can be the hard disk or magnetic tape. How the data will be accessed from this memory that can be a sequentially, or it can be a random access, or it can be by using the various methods like B plus tree or hashing method or indexing as well. So developer would know usability, size of the memory and accessing frequency, which makes easy to design this level, because we need to handle the huge large data, and that data has to be accessed by the various user frequently. The block of storage and the amount of memory used for this purpose is kept hidden from the user. So how much memory it is required, how the data is stored in the form of blocks, amount of memory it is used, that is also hidden. So that complete is nothing but the physical level or the internal level. So this is the lowest level of the data abstraction. Second is nothing but the conceptual or logical level, where we create the complete database. We also call it as a conceptual view. Conceptual view is the information model of the enterprise, complete enterprise, and contains the view of the whole enterprise without any concern for its physical implementation. How the data is going to store, where it is, but we have to cover all the data which is related with the enterprise. The conceptual level describes the structure of the whole database. This level acts as the middle layer between the physical storage and the user. It explains what data to be stored in the database. So if it is related with the hospital management system, then which data we have to store about the doctors, about the nurse, about the operations, about the patients, etc. So that we have to identify which data we have to store in the database. There is only one conceptual schema per database. The database administrator and the programmer use the logical level of abstraction because they want to specify that what data has to be stored in the database and how the data will be retrieved through the various application programs. The next is external or view level. So this is the highest level of data abstraction. This level describes user interaction with the database system. Many users are not aware of technical details of the system, and also they need not access the whole information from the database. As we can see that if the teacher is there, then the teacher role is different as compared to the students. So student can see the details about his or her marks, but the teacher can see the marks of all the students. So teachers have different roles, students have different role. Even if we consider the principal of the institute, then principal has different rights. So all these are the various users that access the same database, but their roles are different and their accessibility is also different. This may be a restricted view of the database and the same database. Similarly, if the bank database is there, then the role of the employer, employee of the bank, they have different roles. Then admin has the different roles. Officer has the different roles, or the bank manager has the different roles. So this may be restricted view of the database and the same database. Multiple views can be created for the same database for multiple users. So multiple users in the bank get different views. And the external, this is also called as the external or view level. Okay, so this is all about the data abstraction. Now the next topic which we are going to study is the data independence. Now, what do you mean by data independence? We have studied three levels. One is the physical level, second is the logical level, and third is the external level or the external view or logical view or physical view. So when we change something at the data at the physical level, there should not be any effect on the logical level. So that is called as the physical data independence. Similarly, When we do any changes in the logical level, then there should not be any change in the external level, that is called as the logical data independence. So what is the overall definition of the data independence? Data independence is ability to modify the schema definition in one level. Okay, so if I do the changes at the physical level at one level without affecting the schema definition in the next higher level. So below layer or level, when we change, there should not be effect on the above layer. When we change here, then there should not be changes in this schema. So there are two types of data independence. One is physical data independence, which is between physical and logical level, and logical data independence, which is between logical level and external level. Okay. So if I change something here in the physical level, then there should not be any effect on the logical level. Logical schema means, for example, if I collect the customer ID, customer name, customer address, and after a few days, if I think that we should also collect the Aadhaar number of the customer. So that Aadhaar number we can add here. Or we can, if we think that the customer ID, name and phone number it is there, I don't want to add the address of the customer. So instead of that, if I add the phone number, then it should not affect the application program at the external level. So if there is a change in the schema, then there should not be change in the external level. So there are two types of physical data independence and logical data independence. First, we see logical. Logical means here, this is the logical between the external level and the logical level. So whatever I have explained, we'll again understand. So logical data independence means it is the ability to modify the conceptual schema without requiring any change in the application program. So your application program or web browser, web application, Android application will not change, although if I change the logical level. So modification at the logical level are necessary whenever the logical structure of the database is altered. Logical structure means if I think that the string as an address of 50 character is not sufficient. I should increase it as 100. If I want to add a new column, if I want to alter some modification, then that modification is required. But this logical data independence separates external level from the conceptual view. Logical data independence means if we add some new columns or remove columns from the table, then user view or program should not change. So whatever the user interface is there, we call it as a GUI, user interface. Okay, graphical user interface, it will not change. So application program did not know ordering of the data fields in a record. Recording ordering of the records in a file, size of each record, size of each field, format and type of each data item, whether the file is sorted or not. So the application programs where they want to access the data will not depend on any of the logical schema. So that's why we call it as a logical data independence. Means if I add or add any column, add any row, delete something, then it will not change the application program. Now next is the physical data independence. Physical means when I change the physical storage. As I had given the idea about how physical data independence works, it means that when we change the storage location or storage structure from one memory device to any other memory device, or from one uh, server to any other server, then the conceptual schema will not change. So modification at the internal levels are occasionally necessary to improve the performance. So we required many times, it's not like that physical schema will not change. It may change. Internal levels may change. Storage may change. So Possible modification at the internal level are changes in the file structure, compression techniques, hashing algorithms, storage devices. So physical data independence separate the conceptual level from the internal levels. This allows to provide the logical description of the database without the need to specify the physical structure. So my conceptual physical data independence means my logical schema will not change. So if I want to take the patient details, then the patient ID, patient name, patient address, patient phone number, that will not change if I change the physical data storage. Comparatively, it is easy to achieve the physical data independence. So this is all about the data independence in the database. So we have studied two levels of data independence. One is physical data independence and second is logical data independence. The next topic is related with the database application architecture. So in this diagram, we can see that there are two architectures. One is the old and second is the modern. Now why it is called old? Because here there are two stages. So we call it as a two-tier architecture. It means that user interact with the through application programs and application program through the network, it access the database system. So client has the application. So through the application, it directly access the database. That is called two-tier. This is the first level and this is the second layer. Now in the three-tier architecture, there are three layers or three level. One is the client and second is the server. So at the server side, there are two server. One is the application server and second is the database system. So here the clients will not directly access the database application. So here through the application, users access the database system. But here client has the web browser. So that is called as the web application, through which it accesses the application server. And application server where the code of front end is written. So that code will access the database from the database system. So that's why the database system is accessed only through the application server. Therefore, it is called as the three levels or three-tier architecture. Now, we again study the two-tier, three-tier, and one more, that is one tier. One tier means when the machine is same, only one at the same machine, there is a client, server, and database. So when we through my any application program, I access the database on the same machine, then it is called as the one tier. Anytime you install the database in your system and access it to practice SQL queries, it is a one tier architecture. So whenever we write the SQL queries on a SQL prompt, then these are the one tier. But such a architecture is rarely used in the production. We generally go for the two-tier or three-tier. So two-tier means a two-tier architecture is a database architecture where the presentation layer runs on the client side. So whether the client machine is a PC, personal computer or mobile or a tablet, so that presentation layer runs on the client side. Data is stored on the server. An application interface, which is called ODBC, Open Database Connectivity, and API, which allows the client-side program to call the DBMS. Most of the DBMS offer ODBC driver from their for their database management system. Two-tier architecture provides added security to the DBMS. Why? Because at the two-tier, we have seen that there are two levels. One is the application through which client access the database system. So that's why we require this connectivity. For example, if I write the application program through Java and through JDBC, ODBC connectivity, we access the database. So database I can create by using MySQL or Oracle or PostgreSQL or any other organization. For example, IBM uses their IBM database or DB2 database. So three-tier architecture in which there are three levels. One is the presentation layer, that is your PC, tablet, or mobile. Second is the application layer, that is server, and third is the database server. So three-tier schema is an extension of two-tier architecture, and three-tier architecture has three layers. One is the presentation layer, second is the application layer, and third is the database. So through application layer, data is accessed from the database system. Okay. So at the client side, client has the any Internet Explorer, any internet web browser, and then through the application server, it accesses the data from the database system. So in this video lecture, we have studied three important topics from module 1. One is the data abstraction, second is data independence, and third is the architecture. So thank you, so students. Thanks for watching this video. Like, share, and subscribe the channel. Thank you.